logarithms. Don't get discouraged now. If you want to try and solve them, just sit right there. You'll be the master on logarithms without having to scare.
Hey everybody, how you doing? It's me, Mr. Tannen. Just wanted to share my lesson for today, which is going to be continuing with our learning on rational functions, but looking at some rational expressions. I'm hopefully keep this under 10 minutes. Of course, right now, if you're listening, I recommend putting it on double speed if you like, or not double, maybe 1.5, because I do tend to speak slowly sometimes. So, we're going to be looking at simplifying now rational expressions, because often it is the case that we'll get something along the lines of what we see here. It's a rational expression. We have a polynomial divided by another polynomial, but it may be able to be written more simply. And there's a little trick that we're going to need to be careful about with these. So, if I look at my numerator, I notice it's factorable because x minus 6 times x plus 2, I wrote it in the opposite way I said it, but same difference, is the factored form because those multiply to negative 12, add to negative 4, and this is a difference of squares, so this could be x plus 2 times x minus 6, or sorry, x minus 2, because those multiply to negative 4 by add to 0. Well, what I could now see is that, well, I have now factors that can cancel. Remember, I can't cancel these out just like that. That's a common mistake we'll sometimes see. Just like if I have 3 plus 6 over, let's say, 3 plus 0. Well, if I were to simplify this, it's 9/3, which is 3. So whatever I do to simplify should still equal 3. If I cancel these out, I would get 6 over 0, which is undefined and definitely totally different from 3. So we can't just cancel out when it's a part of a sum or difference, only when it's a part of a product. So when we factor, we can then cancel. The only thing is here, we still see actually in my factored form that x couldn't be 2, but it could also, nor could it be negative 2, because that would make this undefined. But when I simplify this to just get x minus 6 over x minus 2, what I see is that I've canceled out that factor that was telling me that x couldn't be negative 2. So what I'm going to do is write a comma, and I'm going to specify something about this, because otherwise my simplified function is actually different from my original function unless I specify that x cannot be negative 2. Let me make some sense of this with a graph. So I'm pulling Desmos over here, and what I've done is I've graphed both functions. And you'll say, well, wait a second, Mr. Tannen, you told me that these would be different unless I include this. Well, let's take another bit of a closer look, because they are indeed different. Well, they look precisely the same, right? The shape of the graph is precisely the same. But let's look what's happening at negative 2. So in my first function, look what's happening at negative 2. At negative 2, it's telling me it's undefined. And actually, if I were graphing this by hand, I would draw an open circle just like that, and it would stay on the graph. Whereas if I do this one, it's actually a different function, because what's happened at negative 2, it tells me I have an output of 2. But we know that's impossible. So that's why we need to include this x is unequal. I don't know if Desmos will allow us to use that notation. But another interesting thing, this is what Calliope in 8.3 showed me. If I graph the vertical line, x equals negative 2, look, you know how normally on Desmos it pops up with the intersection point? Like look here, if I do this one without that, it shows you it intersects. But if I graph this one, it doesn't come out as a point of intersection, even I click there. Well, it's because it's not actually intersecting, it's passing through the hole. Very interesting. That was a nice observation by a student. So that's why I need to include the fact that x can't be negative 2, because otherwise my simplified version is different from my original version. Alright, let's look at another example here. And this is going to include a bit of the same step, but in a different manner. So what I'm going to do for this is think, okay, multiply fractions, I go straight across, bang, just like that. So if I'm going to multiply these fractions straight across, I could rewrite it in this manner. Well, let's take a look. I could just go ahead and make it 56 in the numerator. I could make it x to the 7th. And then I could, make it y to the 4th, just adding the powers. And then 8xy to the 3rd in the denominator. The thing is, it might be helpful in this case actually to write it out as its factors, to then divide out common factors. So I see I have an 8 here, so why not break that 56 up to 8 and 7? Because this may be more easy for me to visualize. I have an x here, so let me rewrite that x to the 7th in this manner. Some of you may say, Mr. Tannen, I got an x to the 3rd, so let me rewrite y to the 3rd, so I could rewrite y to the 4th as this. Some of you might say, Mr. Tannen, I don't need to do this necessarily. Well, that's okay if you don't need to, but I think it does help visualize it for everybody. Then I got 8 times x times y to the 3rd. Well, look what's happening now. 8 divided by 8, and look, they're all being multiplied, so I can just go ahead to cancel. X divided by x and y to the 3rd divided by y to the 3rd is just going to leave me with a 7 x to the 6th times y. What's in my denominator? Oh, nothing, so it's just this. Hold up a second though. If I look at my previous format though, x and y, did I have limitations? Well, I did, because I have x and y's in the denominator. So that means that x couldn't be 0, nor could y, because then I would be dividing by 0. But I've eliminated all my denominator. So in this case, I'm going to need to specify that x cannot be 0 and y. Neither x nor y can be 0. I'd love an opportunity to use a neither nor. Beautiful. Alright, so these are some 2 examples you can take a look at here and pause, rewind. But I'm going to then ask you to do a few examples for today's class of simplifying, but specifying the simplified form, any limitations that you may have eliminated. For instance, here saying that x and y couldn't be 0 because we got rid of an x and y in the denominator. And this one, x couldn't be -2 because we got rid of a factor of x plus 2 in the denominator. Have a great day, everybody, and much love to you all.